Hello everyone, and I would like to today show you how you do the Moving Man lab. So after downloading the Word file, which is this one, and so you have downloaded the Word file. It says here what you need to do. Well, please read through it. And I would like to show you how to do this lab. You can click on this link. I prefer to simply go to the website. So let me go to the website and then show you how you do it. So I go Google phet.colorado.edu, click on it, and preferably be using Google Chrome. And let's see here, simulations, click on them. I will choose physics. And let's see here. I'll download. Since it's about motion, I will just uncheck all of these boxes except for the motion box. And they have different formats. So let me go back here. They have HTML5 and this one Java via chirp. So let me just check these two boxes, and then the moving man will be somewhere here. You can just search for it or just scroll until you find the moving man, this one, the moving man. So it's here, so click on it. So you can simply click on this and play it on the browser, or you can download it. So I will show you when you download it. I have downloaded one myself, and then I will show you how it works there. I'll show you if you want to open it on the browser. To download it, you need to have your Java updated. Uh, if you're working with Mac, it's kind of a hassle. You have to do a couple of steps, but in a PC, it should be easy. But let's see. But either way, you should be able to play it on the browser. So click on it, and let's just play it on the browser. And then I will use the one I downloaded because it's just a higher resolution. PhET, they're working on converting all of their simulations to HTML5, but while they're doing that, we will have to use this particular version. So it takes a good minute. Okay, just wait a little bit. So the moving man is starting up. Let's see. All right, it opened. And let me now show you when you open it on the when you download the file. So when you download the file, I have downloaded a bunch on my computer here, PhET, and I have the moving man is one of them. So I have a bunch of labs, but this is the moving man. Let's see. So here it is. I prefer this because it's just a higher resolution. So here's the lab file. Let's check it out, what they want us to do. There is part one. It says, it asks us to set a different one setting. It just wants the velocity constant, meaning the acceleration is zero. I'm going to go to number two. I think it's more informative for me to show you how to do number two. So I'm going to work through number two with you, and then you will complete the rest of these. So all of them are similar. You will be answering the questions and so on. So let's see what I mean. So I will do number two with you. So it says set the parameters as follows. X initial equal to x is equal to 0, v is equal to 0, and a is equal to 0.5. Let's see. X position is 0, v is 0, and I would like this to be 0.5. Okay? And then I will put play, and then I will collect the data. I want to collect what is the position when the time is 1 second, and what's the velocity at t equal to 1 second, what's the position at t equal to 2 seconds, 3 seconds, 4 seconds, and 5 seconds. And then I want to graph it and so on. So let's collect the data first. Probably the easiest way is to just let the man go until he almost collides with the wall. I will stop him before he collides on the wall. And the time is here. So let's see. Let's just give it a try. So he's going, and going, and going, and going. So That's good enough. I want up to 5 seconds. Um, I could have collected data at every, like paused it at the exact time at 1 second, 2 seconds, but I think it's easier to just click on the playback, click the playback here, and at t equal to 0 I already have the data point. So let me pull this to 1 second here, 1 second. So at 1 second, the velocity is 0.479 and the position is 0.23. So 0.23, 0.479, 0.479, 0.23. Let's go there. Point, uh, 0.23, 0.7479. All right, let's go to the next one. I want at 2 seconds, 3 seconds, and so on. So let's just, please bear with me. So at 2 seconds, okay, at 2 seconds, I have the position is 1 and the velocity is 1. You may have slightly different numbers than me. That's fine. That's fine. It just means it's maybe it's 2.05 seconds or something like that, or 0.024 seconds, or maybe it's 1.95 and it's rounding it to 2.0. But that's okay if you have slightly different. Anyway, it should be around 1 for position, it should be around 1 for velocity. So for me, it was nice numbers, so I just put 1 and 1. All right, let's go to 2 seconds. And let's go to I'm sorry, let's go to 3 seconds, I should say. So at 3 seconds, 2.313, let's see, 2.313, and then 1.521, 1.521, and then we go to 4 and 5 seconds. Four, 2, 4, 2, and then 5 seconds. Again, the numbers you may get may be slightly different, not exactly 4 and 2 on your end. So I will go to 5, 6.25 and 2.5. 6.25 and 2.5. Okay. 6.25 and 2.5. Okay. You see the velocity is increasing by increments of about a half because the acceleration is 0.5, right? It means the velocity is changing by 0.5 every time. So let me just copy this table, control copy. I have Excel open, so I will just go here and I will just post like so, maybe. Yeah, like so. And I'm going to, oops, I'm going to do the following. I want to, this one here, I will paste it here. And I want to copy the time again. I want to make two different plots, one for velocity versus time and one for position versus time. Oh, let's just, I didn't put copy, I put cut. So I should put copy. Okay, I think I have it. So to plot position versus time, so let's see here. It says plot the position on the y-axis and the time on the x-axis. Let's see. Okay. So you shade this, and I have a video on how to plot using Excel and using Google Sheets. For Excel, here it is. Again, if you're using a Mac, it may be slightly different than this. So I put insert, go insert, and then charts. Please don't choose this one where it connects it by some line segments like that. Don't do this one, don't do this one, don't do this one. Here's what I want, just scatter, just the data points by themselves. Always do this, just the data points. So that's what it is. I put plus here, axes titles. I have time in seconds on the x-axis, time in, or you can just put, you can write the word time, or t in seconds, something like that, that works also. Or, and then here x in meters. And here I have position, nope, right here, yeah, here, position versus time. Okay, so I have that. And all I'm doing is one plot. So it says plot it. What's the shape of the plot? Let's see what's the shape of the plot. Seems like a curved up uh, parabola or something, like a concave up curve. Um, it's a parabola, by the way. And then it says use the Excel and then fit a second degree polynomial, also known as a parabola. And so let's do that. So I right click on one of the data points, add a trend line, and then I want not linear, I don't want logarithmic, and let me, yeah, it just rejected that. Let's see, I want polynomial, and it's not degree 6 or whatever, it's just degree 2, okay? Degree 2, and I would like to display the equation on the chart. You can display the R value to tell you how well it fit, okay, that's also good. So that's my equation on the chart. I can make my numbers a little bigger. All right, that's the equation. So let's see. Here's my plot. I can make these numbers slightly bigger if I want, right? I can make them bold. Um, I can make, yeah, these numbers on the x-axis also uh, bigger, bold. That's the formatting. You don't have to make them bold. This is good. I need the equation always displayed, and then the curve here, the axis always labeled, and I'm going to click on it, right click, copy. I'll go to Excel, to the Word file. Here's what it says. As always, copy paste your graph below this line. So below this line, hit enter, delete the E, the letter there, and then I want to paste it as a picture, not as a chart with like the source formatting and so on. The reason you do this, you paste it as a picture, is if you paste it as anything else, if you change or delete your Excel file, you will come to the Word file and then find it empty. You will find nothing. But if you paste it as a picture, it's not affected when you change things here on the Excel file. Okay, fine. So that's that. It says using the curved fit, what is A, B, C? It says here AT squared plus BT plus C. By the way, let me delete this for a moment, and I want to show you, because on the y-axis, just to not to get confused, see, Excel just says this is y, this is x, but on the y-axis we have the position which we're calling x. So I'm going to change that as x, and this one as t, and this one is t. So that's the equation I have. And I'm going to control copy again. I will paste it as a picture again, as a picture. Okay. So this is nicer, I think. It's because this is instead of saying y and x, well, on the y-axis I have x, and on the t-axis, on the x-axis I have t, the time. Okay. So I have this capital A is what's in front of t squared. That's 0.2459. B, what's in front of t is 0.0242, and so on. Okay, so I have that. I ask you a few questions, and then it says, now plot the velocity versus time. So let's do that for this one, for the velocity versus time. Well, we will just shade this, go to insert, scatter, boom, and let me scroll down, and I will, let's see, put the plus here, label the axes. Again, you will put time in seconds, and here it's velocity in meters per second, and this is velocity versus time. You can right click on the data point, add a trend line, and in this case we ask you to fit linear because the acceleration is constant. The shape of the plot is it's linear, and then we will it is linear, and we're going to add a linear fit to it. So just linear. As usual, always display the equation. You can put the r squared, not necessary, but just to be complete, I put it there. You can label your chart and so on. You can, where is it? Chart title. Yeah, title here. That's the title. Velocity versus time, something like that. And then you would control copy, and then I will go to here, as usual, below this line, paste it below this line, like that, and then paste like so. Okay, and so that is that. And then you will be answering the question, what's the shape of the plot? I will hit enter, and then I will say the shape of the plot is linear. So, and you will be answering the questions, preferably you will be typing them and so on, preferably in a different maybe color, maybe blue, dark blue, something like that, or, or your preferred color. Um, and save, and then you will be entering this. By the way, as you enter things, you see how the table here is split over 2 pages? Please don't do that. Always make sure that the tables, if you need to hit enter, 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 make sure the table is completed within 1 page. Don't split the table over 2 pages because you will lose a point for doing that. And again, whenever there's a question, you hit enter and you answer. Okay, you answer what the what your answer to the question is. That's all I needed to say. So let's keep this short, and again, you will complete this for the rest of the lab.